Today I'm going to go ahead with aggregation to calculate the number of employees per project. Yeah. So please write down a query where we have the number of employees per project. Okay, then I will provide the solution. So we have now the title of the project and the count of the members of the project. For example, count last name. So actually, if we're talking about rows that should be in there, I would prefer to have a count star here. Yeah, that makes it more clear. But the result was correct before, but it's just a matter of taste here. But there was one requirement: only projects with more than one member should be in the output. So what do we have to add? We need this having clause, yeah.
Having
So,
count.
yeah. So let's see. So I have already prepared that. So I put it here. Yeah, and then I will execute mine here. Yeah, you see now that we do not see the CIM project because we have having count star greater than 1. Yeah, and I have also provided the required renaming here. Yeah. Okay, so I will put it in the chat. For you to copy it, and I will do the following. I will also make a copy of that slide here, and I will copy over the solution here so that later on, if I put the slides on the internet, I can you can have the solution together with the text. Yeah, that was the question. That was the exercise. Okay, so now, okay, maybe we should just once again look a little bit at it in order to understand what we have here. So let's make it a little bit more. Let's format it a little bit here. Yeah. Okay, so the structure is we have a group by here, as you see, group by title, and then the title could be in the output because we are grouping according to title. And if you look at the company data model, so what has been done is we have taken the project here, and we have taken the employee project table here and have connected them. And for example, if I take project ID number 1, you see number 1 appears 2 times here in the employee project table. That means that accounting will appear 2 times in the resulting join, and that means that where I am, here I am, and that means so here I am. That means that accounting appears 2 times here. Yeah. So that's the point. If I'm joining the project and the employee project table here, yeah, if I'm joining them, I get repetitions of the name accounting, and then if I group according to the title, as many repetitions that I have of accounting, as many records I have in that group, and if I count them, then I get the corresponding number. Yeah. Okay, so that's the essence of aggregation and grouping. Yeah, and now we can um, we can again take a look at our cost example that we have developed last week when we have talked about joining things. And as you remember, last week we have calculated the cost per employee and per project. Yeah. And we have the following parameters. We have, yeah, Shobham, you have a question?
Yeah, Professor. In last query, could you just open that employee table? Like I have some confusion.
Uh, this one, yeah.
Yeah. So here, we are joining like a project PID with employee PID. Uh,
Yeah.
yeah. So could you just open that table that shows the layout? Like
So, what?
not this one, like that. The one with with the one with the solution, like every table, like employee table.
The model.
Yeah, model. Yeah, model. Yeah.
So that also the employee table is in it.
No, I have this professor query in that model, like the question that you give, like from which like there is the number of table, like employee table, project table, the data that data set.
Yeah. Yeah.
Yeah. So yeah, professor, like here, like can we join like if there is no direct connection between PID and this PID?
So we have joined the project table with the employee project, and your
Yeah,
question is
yeah,
what?
yeah. Like so my question was this. Yeah, here like Neeraj has joined employee EID. Yeah, okay, no, sorry. I got confused. Yeah, it's fine. So I was just asking, like, is it possible to join this project with this employee,
Yeah.
this project table with employee? So that
Yeah.
was it.
If I join the employee project table with the employee, yeah,
Yeah,
um, that
because
would
like
be,
there is no direct connection. So that was I was thinking like PID with we join with project and the data is in employee table. So how it is giving this data from project employee table?
yeah. Uh, then we cannot directly join the project table with the employee table. It is only
Yeah.
possible via the employee project table. There's no other way to do that.
Okay, so we can do in that way, right? Because I was thinking like there must be any connection, like there should be direct connection between employee and project. So we
Yeah,
can go through this multiple
that
connections.
you must go via the employee project table because
Yeah,
the PID is in the, so you cannot connect PIDs with EIDs. That doesn't wouldn't make sense.
yeah.
So you can only connect PIDs with PIDs, and that's in the employee project table, and then you can connect EIDs with EIDs. Yeah.
Yeah, okay. Okay. So just like EID has connection in employee project, so these three tables are interlinked. Is it like that way?
As you remember, we have this many-to-many relationship between employees and projects, and that is why the employee project table is there, and therefore there is no other way to deal with it besides using the employee project table.
Yeah,
But
okay.
but
Yeah,
in this case here, yeah, because I only want to maybe so the one thing that could also have been done is that you add the employee table here, yeah, but that would not be that is not necessary because I'm just counting the number of employees. I'm not taking any column of the employee table. And therefore, it's perfectly okay to just rely on the employee project table in order to count memberships.
yeah. Okay, thank you. Because I got confused, like because there was no relation seen, so that's why I asked the question.
Yeah. Okay.
Yeah.
So then, once again, you remember we have talked last week about the cost that each individual employee allocates to a project. And we have made the following assumptions. Every employee is working 40 hours per week. And you remember, if I take the fraction of his time and accordingly the fraction of his salary, that's the cost. Yeah, that is delivered by the specific employee. So if I'm working 40 hours a week and I'm 10 hours within a project, 1/4 of my salary is allocated to the project. Yeah, that was the idea, and the overall project lasts for 1 year, and we have only this labor cost, and we only consider salary. That were the parameters of this cost calculation. And now, since we have aggregation available, I would you to figure out how the overall cost for each project can be calculated. And what is meant by that? Yeah, if there are two persons on one project, I have to sum up the cost of each of the singular person, and then that's the cost of the project. Yeah. So please. So the exercise before was just the number of employees per project, but now I would like to have the cost per project. So let's see. First of all, what was the requirement? Projects and overall cost, and the idea is that that the cost per project is calculated. Yeah, but here we have plant restructuring 2 times, accounting 2 times. That still is the cost per employee and per project, but not per project. Yeah, and there's a second thing. If you look at the calculation here, the salary here, that's the yearly salary. So it's not the weekly salary. So multiplying by 42 is not okay here. Yeah. So it's and since the project lasts for 1 year, that was the simplification I have made. I could just take the yearly salary and multiply it by the fraction of the time. Yeah. So once again, here this is the what we already had last week. That's the cost per employee per project. What has to be done in order to turn that into the cost per project?
Professor, when I was putting distinct in front of project title, then I wasn't like getting rid of this plant restructuring.
Yeah, that's because it just talks about distinct rows where that it only unifies those rows where each column has the same value. So accounting 25,000 and accounting 20,000 would still appear because they are different rows. Yeah. So distinct is not the solution here. It's distinct is what is needed here is aggregation. Yeah. So any ideas how
Some function or something we can use for.
we have to use the sum function? That's perfectly correct. Yeah. But in order, so I can do the following here. I can. So we have to sum up the cost elements. Yeah. So the summing here that is necessary. But if I execute this, I get an error message. So what is the error here and what is needed to do?
Some should only be for the salary, maybe.
No, we are summing up the costs, and the cost is salary times that fraction of time here. We have to group things.
Yeah.
So, and according to which column we have to group?
P dot title.
P dot title, yeah. 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 This is so without this grouping here, yeah. Now let's do it. Let's take. So just a moment. So if I remove if I remove this one here, and then I also have to remove that one, yeah. So now I execute here the two queries. So the first, this is without aggregation and without grouping, and you see we have accounting 25,000 and accounting again with 20,000 and so on, yeah. And now in the second one, we take all those rows that have the value accounting in it and sum them up. So accounting 45,000, CRM 25,000, plant restructuring 70,000, yeah, 70,000 here. Yeah, you see it? The difference between the two things. The first is without aggregation. It's just the detail elements, the single cost elements for each employee here. And now it's aggregated. Yeah. Okay, so I have also to have the correct names here for the output as I wanted to have it. Yeah. Oops. There's a minor typo. Where's the error in my solution?
PID is equal to PID.
Here's the error. Yeah, I've joined with the employee table, and you see I have from employee project I have taken the project ID and have compared with the EID. Yeah, this is a typical error that could happen. Yeah, of course I have to compare corresponding values. Yeah. So, and now 45,000, 35,000, 70,000, yeah? Now both are okay. I would like to get you all those projects that overrun budget. Yeah, and maybe we should, I should, let's first remove this one here.
So, Professor, the cost is wherever the cost is more than the budget.
Exactly.
Okay.
And you should figure out how the query looks like to figure that out, yeah? Starting point, of course, should be the solution of the project cost we already have. And you have to extend it in order to figure out. At the end, I would only like to have those rows in my report that tell me which projects are over budget. So, okay. There are two solutions. Okay, there's one solution from Niraj. Where is it? Yes, it is. So this is one solution here. And the second one is from Xavi. Oh, the Xavi has provided a second alternative. I take the second one, yeah. Okay, let's see. Let's take the first one here from Xavi. And not Xavi, from Niraj. And you see the budget was 10,000 and the cost of the project was 25,000. And let's see, Xavi's solution is the same, yeah. Only the column name here is, it's actually, it's completely the same solution, yeah. So let's concentrate on this one here. So the starting point is the calculation of the project cost. That was the query we have done before. And now we need a condition on the group level. And the condition on the group level means that the sum of the individual cost of the individual employees, that is the overall project cost, should be greater than the budget. The problem here is, let's remove budget from here. If I remove budget from here, I get an error message. And that's because I'm going to use budget here on an aggregated level, but it's neither in the group by nor is an aggregation function applied to that. Yeah. And now there are two solutions: either put it in the group by or put an aggregation function around it. And usually if I add a further column into a grouping here, it would deliver many more groups, because I have combinations, yeah. But in this case, since title and budget come from the same table, that means that within the join for each title value, we always have the same budget value, because they belong to the same table. And therefore, now we have we fulfill the formal condition that it must be either in the group by or it must an aggregation function. So in this case, we have put it into the group by. Yeah, that is one solution, and that's perfectly okay. Yeah. So just copy over this, the solution from Niraj. Yeah, that's fine here. And now let's discuss the second possibility. So if I remove the budget here, yeah, then since every detail record has the same budget here for the same project, yeah, I can also use the following. It doesn't matter. I can use, for example, take the min, because within that group, all budgets have the same value because it's the same project. Yeah, I can just take the min, yeah, here, and oops, and I also have to do it here, of course. Yeah, then it would also work. But instead of min, I can also use max, for example. Yeah, that would be the same. Wouldn't matter. Yeah, both solutions are possible here. In this case, I would say this one here is the more natural one. Yeah? It looks better here to put the budget into the group by. Yeah, so let's remove that here. And okay, that's a solution. Yeah. Okay, now you see that that we have a powerful way to do analytics on data. For example, this is something that is not just summing up data, but is checking a real business condition, namely projects that have a bad status now, yeah, because they are over budget. So if you have a huge data set, yeah, and you would like to try to figure out problematic things, yeah, SQL is the way to do that. Because you can formulate complicated conditions, yeah. Turning our attention to the Foodmart example, yeah. So you remember the Foodmart was about sales facts with respect to customer products and stores and dates here. Time dimension is also available. Yeah. And this query here, there is one keyword we haven't seen yet. I have used it here because it's quite useful, that you can provide union of the results of different queries. So for example, you see this query, yeah? So if I put that query here into the DB visualizer, yeah, you see, I just, of course, I have to switch to the Foodmart database. Yeah, you see in the output, I get the string value customer, that's just the constant value. And the table name I'm going to use here is table. And then I take count star, so all records of the customer table. Yeah, and let's take a second one here. Let's take, for example, the stores here. And if I execute these two queries, I get one query here, table customer count 10,000 something. And here I get the second one, table store count 25. So these are two different queries. And you see they have the same structure. They have a column name called table and they have a column name called count star. Table count star. They only have a different record in it. And if you have tables that have the same structure, yeah, you can put a union between those tables. You have to remove the semicolons here. It's just one single query now. That is a union of a bunch of queries. Yeah. So if I take this one here and execute it here, yeah. And that's quite nice. So if you would like to get an overview of your data, and if you get some data and you don't have any, you haven't seen it before, yeah. So you would like to get the first idea about the data, then counting data is a good idea, yeah. And so that that query allows that. I put it here in the chat, yeah. Allows it to do that, and you get an overall view of all the tables. Yeah, you see it here. Okay, that is one thing I wanted to show to you. That just counting, yeah, from the aggregation point of view.
Professor?
Yeah.
Yeah, just wanted to ask, like, how did the row name become sales? I'm not sure. Like, sales is a table.
Yeah.
Little bit confused.
Yeah. The point is, you see, I have enclosed sales in single quotes. Yeah. And enclosing something in single quotes means it gets a constant textual value. So the value of sales within single quotes is just the string sales. And that's what's happening here. So if I take customer in single rows, I get customer as a value. Yeah, it's just a constant value. Maybe you remember this, what we have done with
One as one.
number one as one when we have talked about expressions. Do you remember?
Yeah, yeah.
And that's the same thing here.
Okay. So then string in single quotes will be row title or row.
That's just the value of a singular record in a singular column. You see, customer is only one in that the overall column here of that query is table. Yeah. But for the first record, we have the name customer, and that's what. So executing this here delivers you the string customer.
Okay.
And here you see double quotes. And that's in order to have specific table names, for example, table names in lowercase letter here. Yeah. If I would have removed the double quotes here, I would get it in capital letter because the database automatically capitalizes things.
But still it would work, right?
Okay. So, and you remember last week we have done this analysis here of the product hierarchy. Yeah. So we have taken the product table. So here's the product table. We have taken the family column here. And we have grouped according to family. And we have just counted. So we get all the available families with a number of products
Yes.
within that family.
Yeah. Yes.
And in the second one here, we have grouped according to department. You see there's also a department column here.
Yeah.
And we got all the department, and we count how many records are within each department. And then I have done a combined grouping, family and department, and we found out, for example, that we don't have a real hierarchy here. We have a so you see we have 22 departments, but department family combination we have 23, and we have figured out that diary is as in the drink department, yeah, as well as in the food department, yeah. And you see here it is splitted 25 within the drink department and 75 within the food department. Yeah. Of course, diary within food looks like an error here in the data. Yeah. But if you look at the department table here, you see diary, because we have aggregated all values here. We have the value 100 here. Yeah. It's summed up. That was an interesting finding, I would say. Yeah. If somebody tells you, yeah, something is a hierarchy, and you find out that that is not really a hierarchy, yeah, you have found an error in the data, and that might lead to complications later on. Yeah, for example, if you combine this here, this calculation where you have the overall value of diaries, and you combine it in an unsuitable way with families, for example, you might count diary twice, and that gives you a wrong error. Yeah, I'm not going into the detail how that could happen here. Yeah, but that's a problem if something is in different groups. Yeah, and you have countings on different levels, and then that might lead to wrong values. So in the same way, we could analyze the customer dimension, but because we have not enough time here, I'm not uh, giving that as a exercise here. And the same is with respect to analyze customer dimension with respect to influence of education level to income. Yeah, but I show you a query here that provides some insight into education and income. And I think all of you would assume that the better the education, the greater the income. Yeah. But that's not easy to figure out directly within the data. If you look at the data here, yeah, if you take directly the values here, because we have so many records here, yeah, we could not see that immediately. But we can use SQL in order to figure that out. And let's first take a look here at the query. Yeah, that looks quite complicated, doesn't it? Yeah.
Yeah.
But now let's see what I have done here. Let's first take a look at the table, at the customer table. Yeah, if I just take the output of the customer table here, yeah. So you see that, for example, we have yearly income here, and we have education. So here's a high school degree person who earns that, and here's a partial high school, and we have a bachelor here, yeah, and then we have many more records here, yeah. Where
Just one question.
yeah.
Yeah, the yearly income column, the data in it, is it considered as a string or an integer?
Yeah, that's a good observation. Actually, it's really a string here. So it's a category more or less, yeah, and that is stored as a string.
Okay.
And that even complicated things, yeah. So, for example, the ordering of things, yeah, is so. For example, if I take this yearly income column, yeah, yearly income, yeah, and let's put a distinct in front of it, yeah, and from customer and order by, yeah. Yeah, you see 10,000, 30,000, but then 110,000 because it also starts with the letter 1 here, yeah. So that
Mm.
is nasty.
Ascending or descending here? Something.
Sorry?
Can you put ascending, like order by ascending order or something like that?
Yeah, but that doesn't, it's already ascending, yeah. So if I ascending, it is already the same here, yeah.
Okay, because it's not numbers, so that's
That is something that I wanted to emphasize here. Yeah, that obviously is quite problematic here. That kind of coding here that we have. Yeah, and that hinders analytics, yeah, and therefore the query is a little bit more complicated as we have expected. So having that in mind here, yeah, that we have the yearly income as a string value, and as a string, the ordering is not as we would like to have it, yeah. And we have many levels, as you see, many income levels, yeah. And in order to really get insight, I have done the following. So so here's the customer table. That's our center point here. And what I have done now is I have grouped it according to education, yeah. So bachelor and so on, yeah. I have here grouped it according to education, but now I have not grouped it according to yearly income, but I have done the following. I have provided a conditional expression. And you see, I have done the following. I've taken 10K to 30K, 30K to 50K, 50K to 70K, and I have called that simply level 1. And everything else I've called level 2. So I have separated the incomes in 2 distinct levels, yeah, and have put the corresponding income group, yeah, into the corresponding levels. And therefore I now I have the group L1 and L2, and therefore I also need the same thing here in the output. And now you see we have level 1 and level 2 and so on. And now we get much better overview of our data. So let's take for example graduate, a graduate degree. And you see there are 501 customers that have level 2 income, but only 38 with level 1 in the graduate degree, yeah. But if you take partial college, for example, you see there are only a few 140 in level 2, but the majority is in level 1, yeah. And now we actually see, we get insight, and we can confirm that the higher the education level, the higher the income. Yeah.
Professor, could you please explain this again? Like, I didn't understand these 2 cases.
Yeah. So this case statement here, that conditional expression. Yeah. Maybe we should do the following. Let's take the case here, and then you get a better impression what is happening. Now I take let's take just a moment. Let's take it's called customer ID. Let's call the last name, yeah, here. So I take last name, and then I take this case statement here, yeah, as level from customer, yeah, and no ordering here is now needed. So let's see what we have here. First of all, we have an error. What is the level is not allowed here, yeah. Let's call it level, yeah, because it's a keyword, yeah. So I take all the customers, and for all customers I take the yearly income column and convert it into L1 and L2, and then you see L1, L2, and so on, yeah. So this case statement provides for each customer now his yearly income level, and I have decided, as I have designed it that way. I have differentiated in two levels. Yeah, so that's totally up to the one that does the analytics here. Yeah. So if you would like to distinguish between three level, you could change the case statement accordingly. Yeah. That is what is happening here in the output. And I also use these, I do not use the income itself for grouping, but the level. And that's a flexibility that we have here, that we can take also a calculation and use the result of that calculation as the criterion to form groups. Yeah. Does
Yes.
that answer your question, Niraj?
Yes, Professor. But we have here two cases. So I just wanted to know, like, why did we put on the first case, like, then the second case, and putting the two cases, does it affect on each other? Are they reliable on each other?
So since I'm grouping according to the education level and with respect to the level, for each education level and each annual income, I count all those customers that are within that group.
Yes.
Yeah. And then looking at the data, now this is insight and understanding that you must have. Yeah, that you see, okay, if I take a higher degree, like a graduate degree here, for example, then I see most of the records are in level 2. And if I take a lower education level, yeah, it's the other way around. And so I can verify, or can I get the insights. So you are, as the one who analyzes the data, you are in the driver's seat, and you select what levels you would like to have, what columns, what you would like to put in that level, and so on. Yeah, that's not something that is cast in concrete, but it is just your to follow your goals, what you would like to get out of the data. Yeah, that drives you to provide that kind of query.
Professor, one more question.
Yeah.
Like in the first, second, third, fifth line, we have used and as annual income and then comma count star.
Yeah.
So if we use this count star in the select statement like before, will it make a difference? I'm not sure.
Can you repeat it, please?
Yeah. In this line, and as annual underscore income, comma count star.
Yeah.
So if we use this count statement in the select, that is the first line.
That is part of the select.
Yeah.
As a first, you would like to use it as the first position here?
Yeah, first or second. Like after education also would be fine.
It doesn't matter.
Okay.
Doesn't matter. It's just so if you take that one here, yeah, let's so we have column education, then we have a second column that looks a little bit more complicated, annual income. Yeah. I have called that here, and then we have last column called count. So if I remove it here, yeah, and put it in here, yeah, I get the same thing, but only the count
Okay.
is at a different place.
Yeah.
Yeah. Okay. Yeah. So that was an example of a more complex kind of analytics. Yeah, and this is something later on we will use visualization tools in order to visualize data, and so that of course is quite nice and much more easier to use than doing things in SQL. But the real power to gain insight from data is having the possibilities of SQL at hand. Yeah. Okay, so
Okay, so
Professor,
can you please put this in the chat, please?
yeah, of course.
Professor, in like after group by education, do we need to put this case like second case? I
Sorry, can you repeat it? I didn't got it.
Yeah, in like after group by education, do we need to put this case second case? Because like
Yeah.
even though like it will be grouping by education what we want, because we have put one case in select statement. So do we need to put this second case?
The other way around, it makes sense because we have grouped according to that to the result of that expression. Yeah. In order to allow this column here, this calculated column here in the output, since we have no aggregation functions on it, it must be in the group by. So the starting point is that I have figured out how to group things, and then I could also put it here in the output. So after having done that grouping here, it is necessary to have it in the output to provide the same calculation here. Otherwise, you would get an error message.
Okay, thank you, Louis.
Yeah. I admit that that's quite something that you have to absorb, yeah, to understand how. But that shows that is an example how the flexibility you have in that you can do grouping of your data, yeah, and joining data, grouping data, and selecting data, filtering data. That's are the essence, yeah, the major aspects here of analytics. Okay, then last but not least, I would like that's a little bit more easier to understand. I just want to do sales analytics, for example.
Sorry to interrupt. Like the query was not pasted in the chat box. Sorry.
Okay, then I once again. Here we are. So, is it okay now?
Yes, Professor. Thank you.
Yeah. Then the next thing is sales analytics, and I just put it here in the chat. But I also will put these slides later on here on my website, yeah. But nevertheless, you should already get it. And here we see revenue per year, country, and product family. Yeah. Let's do it as follows here. Then we have it also here on that page. Yeah. And so we see the year, we see the country, we see the family, and then we see the revenue, the unit sales, and that's the number of sold units here. The number of sold units, and that's count. That's the number of records within that group. So if we look at the first row here, we see that 2014 USA drink has a revenue of 48,000 something, distributed among 24,000 singular units. And since we have only 8,000 rows here, that means each row has a quantity of 3. Yeah, there are corresponding. That's the connection to that. Yeah. So the query itself is much more simpler than the one before. You group by year, country, and family. You have to join all the tables that are necessary, the sales tables, time by day, store, and product table. Yeah. Only the customer table is not needed in that query here. And then in the output, you have year, country, family. This is from the group by. And then you have the corresponding sums and counts. Yeah. This is a simple first step, yeah, the overall sales analytics, that you just get the summarization of your data. Yeah.